Welcome guys, let's solve another LeetCode Daily challenge, score after flipping matrix. You are given an m times n binary matrix grid. A move consists of choosing any row or column and toggling each value in that row or column, i.e. changing all zeros to ones and all ones to zeros. Every row of the matrix is interpreted as a binary number, and the score of the matrix is the sum of these numbers. Return the highest possible score after making any number of moves. And this is very important because we are not limited to the number of moves we can make, and we don't have to track all these moves. This simplifies our challenge, and the main all these rows represent some value, and we need to maximize all these rows and return the sum of all these rows, and this is our task. And let's talk about binary numbers a little bit. Let's take the first example. In the first row we have the following binary number, and this binary number represents 3. And let's talk about the way we can maximize this binary number. We have deleting zeros and 2 ones, and in binary numbers the leftmost bit is called the most significant bit because it affects the value greatly. Because, for example, if we flip zeros to ones, we'll get the following value. We will get 1, 1, 0, and 0, and this represents this represents 12 because it gives us 8 and this gives us 4, and this will give us 12. And let's take another example. We have this binary representation, and see, no matter how many ones come after this bit, because this is still the most significant. If we let's add 1 bit as well to the end, and if we flip it to 1 and all these zeros, all these ones to 0, we'll still get this number greater than this one, because this will represent 7 and this one represents 8. And this is the idea. All we need to do is to check to take the row, for example the first row, and maximize this row, and we'll maximize this row by flipping zeros to ones and ones to 0, and to check whether this value can be maximized or not, all we need to do is to check the first significant bit, and this is the answer. Because if this value is already 1, if this is already 1, let's take this example. If this is already 1, this this cannot be further improved or increased, because even if as soon as we flip it to 0, and this binary number will get smaller, and that's why all we need to do is just to check the first bit. If this is 0, we can flip these all the zeros to ones, as for example like this. Or if it's already 1, I mean the first significant bit, and this is random binary number, and if the first significant bit or the most significant is already 1, we don't do anything, because it cannot be further increased. And this applies to rows. And then the next step to maximize the overall score is by checking the columns. And this applies to rows. First we'll increase the maximize the rows, and next we'll increase the columns. And let's talk about the column-based approach. Let's take this example. We have 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. And this is our matrix. All we need, the idea of the column-based approach is to count how many zeros or ones in any column. Let's take the first column. If this column has more zeros than ones, the number of zeros is more than 1, it means this column can be maximized. If we apply the flipping, we'll get the following matrix. The first bit will become 0, 0, 0, and we are changing the first column, and that's why these zeros will become 1, 1, 0, 0, 0. As you can see, the sum of this matrix is more than the sum of this matrix, because the sum of this matrix is 4, because this row is 4, this is 0, and this is 0, and the sum of all these rows is 4. But in this example, the first row is 0, the second row is 4, and the third row is 4. And as you can see, the sum is 8. We have increased the sum of this matrix, and this is the idea to solve this challenge. As you can see, it's pretty simple. And speaking about the complexity of this approach, in terms of runtime complexity or time complexity, let's say its time complexity, it's O(n) squared, because we have two loops, and two nested loops, and that's why to traverse the matrix we'll spend O(n) squared time. And speaking about the memory complexity, it will be constant time, because we'll need only 1 or 2 variables to count or to accumulate the sum of all these rows to return as a value of this function. And that's it for this approach. Let's jump into coding this problem. First of all, let's iterate over the grid over each row I in grid indices. Next, let's initialize our row, current row, grid I, and we'll check the following. We'll check if the first bit, if the most significant bit of the current row is 1, or 0 if the first bit is not 1. It means this row can be flipped so that the value will be increased. For j value in row with index, and if value is 0, row current value will be 1, else row j will become 0, and that's it. And by this time we'll have already maximized each row, and next we'll increase all the columns. We'll do something similar. We'll iterate for each columns in the grid, j in grid 0 indices, and see this j in grid 0 indices, it will give us the number of columns in a matrix. Next, we'll do the following. I want to count the number of ones in this column. For I in grid indices, if grid I j is equal to 1, we'll just increment ones, and we'll check if the number of ones less than the number of if the number of ones less than the half or less than the number of zeros, and this will give us the middle, or the half of the column. And if if the number of ones is less than the half, it means the number of zeros is greater, and that's why I need this checking. For I in grid indices, we will flip the values in the column. If grid I and j is 0, we'll do something similar. It will become 1, else grid I j will become 0, and that's it. And by this time we have completely increased the overall matrix, overall value of the matrix, and all we need to do is to convert the binary representation of each row to the decimal value. And this is the third part of this challenge, and as you can see, it is pretty big. I mean, in terms of the lines of the code, it's already 25 lines of code. It's pretty long. And next, our next step will be to convert and to sum all the row values. And I'm gonna initialize overall sum to accumulate all the values. Next, grid for each. This gives us each row, and each row stands for the binary representation, and we'll count the sum of each row. And I'll need the following values: base. I'll need the size of the row, and let's iterate over this row down there to 0. Next, I'll take the current bit, row I. If the current bit is 0, we just continue, because if the bit is 0, we do nothing, because it doesn't stand for anything in terms of converting the decimal value. And next, we just increment or sum the sum variable, base power to current bit, and that's it. And it's showing the error because the sum must be double, because this function returns us the double. And next, by this time we have calculated the value of the row, and we just accumulate our overall sum, and that's it. And there is an error because it's saying that the incompatible types. And by this time we have already completed the value, and all we need to do is just to return overall sum, and just let's convert to int, because overall sum is double at this moment. And this is the end of this function. Let's just take and submit our solution. I hope it will be accepted. Well, here there's a mistake, and let me check where I made the mistake. Yeah, it must be a last index for sure. Size. Well, as you can see, our solution has been accepted and it's pretty efficient. And this is the end of this challenge. If you like it, please like and subscribe, and see you in the next videos.